Hey, this is Miss Marshall again, back with part 2, teaching you about simple harmonic motion. All right, what is that? It is a type of periodic wave motion of an object. For example, a spring, like a bouncing spring, like a spring. I can't even think of the other name. A spring. A Ferris wheel. Or a bouncing ball, etc. Something that moves in a back and forth motion, typically at a height. Like it doesn't go no higher than a point and no lower than that same like distance. And this is it. That's what simple harmonic motion is. It's abbreviated SHM as well. The formulas. So there are two formulas. The formulas are D equals A sine of BT. So nothing like totally different from what we've seen. Or D equals A cosine of BT. And these are the two formulas. It just depends on the pattern of your bouncing, which formula you're going to use, just like before. And you need to know that D is the displacement or the distance from the origin of where the object came from at time t. So just underlining T and D to make sure you know what those two things are. And then there are two or three other things. We need the amplitude, which is what it was before. It is the A, but it's the absolute value of A. You can't have a negative amplitude. Negative just means a reflection. And this is also known as your maximum displacement. So that's how high you can go versus how low you can go. How low can you go? How low can you go? Next is the period. And the period is 2 pi over B. And your period is the time to complete, can't spell, a full cycle. And last thing, because I told you there were 3 of them, is the frequency. And frequency is the inverse of period. So it's B over 2 pi and you can do whichever one of these you want, honey. It's whichever one is easier at the time. 1 over period, because it's the inverse. It would equal the same situation. 1 would just be less work. And this is the number of cycles per the time. So whatever the time is, it's however many are in that time. And one last thing to note is that your frequency is measured in hertz. And we just abbreviate that HZ. All right, let's do an example. Whoop, 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 whoop. And I only have one example for y'all, just one example. But it's a word problem, so y'all got to write all this word problem. You can do it, though. It's going to be amazing. A ball undergoes, it's serious like surgery, undergoes simple harmonic motion where 8 centimeters is the maximum, we're going to abbreviate that, displacement, we abbreviate that too. It takes 8 seconds for it, the ball, to move from its maximum displacement above 0 to its maximum displacement below 0 And back again. Woo. A lot of words to just describe the period. Okay. Last thing. Assume the initial, so that's just where the ball begins, position is at equilibrium. Now, let's answer some questions. So I have 4 questions I want to answer. Question A is, what's the equation? Question B is, and we don't need that much space for B. We're going to put B up here. Question B is, what is the displacement at 20 seconds? Question C is, what is the least positive value of T when D equals 3 centimeters? And question D is, what is the frequency per second? And we're talking about seconds anyway, so it's just what's the frequency? All right, so let's begin. Let's start off with a graph. Just like we did word problems before, we're going to start off with a graph, and I'm going to draw sort of a T, but more of a first and fourth quadrant. I want the amplitude at 8, and I want the amplitude at -8 to show above and below. Why? Because it says it's 8 centimeters is the maximum displacement. Also, we're going above and below the x-axis because the initial position is at equilibrium, which is nothing but at the origin. So that means the ball starts here. And when we think about a ball, it takes 8 seconds for it to move from its maximum displacement above 0 to its maximum displacement below 0 and back again. So it's just 8 seconds to go from top going down, then back up. So 8 seconds in all. So we're going to start here, going up, then midline, then down, then midline, and that is your full cycle. So this is the path of the ball. In terms of how the question is worded, it's saying that it's going from the maximum displacement and back up to the maximum displacement again. And they're saying that this part is 8 seconds. Well, if from there to there is 8 seconds, then the picture from the origin to the midline is also 8 seconds. So it's just worded in a weird way. The period is 8 seconds. So let's identify some things. We want to write the equation. It's a sine function because it's going in the sine pattern. A sine of BT. And what we know is A is 8. B is 2 pi over period. And our period is 8. So B equals pi over 4. And yes, honey, we have everything we need. D equals 8 sine pi over 4 T. And we are done. Dun, dun, dun. With that one. Now B. What is the displacement at 20 seconds? Okay, at 20 seconds, D equals 20. So 20, not D equals 20. That's T equals 20. So D equals 8 sine pi over 4 times 20. Let's go ahead and simplify this. Cross simplify. So this is 8 sine of 5 pi. On the unit circle, 5 pi is at the 180 degree mark, and that is -1, 0. And the sine is 0. So 8 times 0 is 0. D is 0. It's back at equilibrium. Your displacement is 0. For C, the least positive value of t when d equals 3. So we said 3 equal to 8. Let's put the 8 in there. Sine of pi over 4 t. Well, we have to solve for t, which means we're going to have to do a little bit of calculator action. Why? Because we're going to have to take the sine inverse. And sine inverse is saying what point on the graph is the sine 3 over 8? Well, there is no point on the graph where the sine is 3 over 8. So make sure you put it in your calculator in radians, and you end up getting 0.3844. 0.3844. And now let's multiply by 4 over pi. And we end up getting, let's move this up a little bit so I have some room to work it out some more. Okay, right there. And we end up getting t equals, and when you multiply by 4 over pi, t equals 0.4894, which is about a half a second. Which makes sense. It's got to be within your time frame of 8 seconds, because 3 centimeters is within your displacement of 8 centimeters. So that makes sense. Half a second. If you did it in degree mode, it would have been something like 22, and that just doesn't make sense. That's way past 8 seconds. So our last one, D, frequency per second. Frequency, remember, is B over 2 pi, or you can do 1 over period. It's whichever one is easier. To me, 1 over period would be easier. And so 1 over my period, period is 8. It's just 1/8. And that's your final answer. All right, that concludes my notes. Have fun practicing. Marshall out.